Alright, the topic that we researched was how a water strider is able to remain on the surface of water without sinking. Our observation that we observed is that water striders are able to skate across the surface at high speeds on the water without sinking or puncturing the surface tension. The hypothesis we came to conclude is that with the combination that water striders' feet have naturally hydrophobic hairs and that the surface tension of water exceeds the force that the water strider exerts on the surface, allows the bug to remain afloat.
If we were to go a little more in detail with the chemistry side of why there is surface tension in the first place, it is due to the water molecules. A water molecule contains 1 oxygen and 2 hydrogen atoms. These atoms have negative and positive dipoles, and because of these dipoles is what allows the water to attract and bond to itself. From this hydrogen bonding, it creates surface tension, meaning that there is a film-like structure on the surface of the water that is stronger than the rest of the structure underneath. Due to their microscopic water-repellent hair in the front and the back side of their legs, and also the surface tension of the water striders are able to stay on the top without sinking. And here is our analysis.
So long as a water strider does not exceed a certain force, it is able to stay afloat. This force, which can be rewritten as mass times gravity, is dependent on the angle of the strider's legs, the circumference of each leg, and the specific tension of water itself. It is able to glide across the water because it minimizes these values to an extent to which they do not exceed the surface tension of water. The use of 6 legs maximizes surface area and distributes weight across the fragile membrane. Also, an extremely small mass paired with very small angles between the legs and water allows the bug to move quickly if necessary.
Why the water strider can walk on the water? Due to the strider hydraulic hairs and physical geometry, they are able to compact air and repel water. The surface tension of water is measured as 72 Daniels per centimeter, meaning it would take a force of 72 Daniels to break a surface film of water 1 centimeter long. Each stroke of the insect's leg creates dipoles on the surface with underwater, swirling vortices, a sufficiency to propel it forward. It is this reverse motion of the vortices combined with an even distribution of the weight that propels the water strider forward.
The legs of the strider let the bug utilize surface tension to float on water. The front and rear pairs of legs handle most of the strider's weights. The side pair controls propulsion through rowing, while the rear legs steer the strider's motion. The front pair deal with hunting. The angle between a strider's leg and the water surface are crucial to floating. For example, a narrow angle creates a stable tension system for the bug. In conclusion, the water strider can walk on water due to the anatomy of its legs and the fundamental concepts of surface tension.